So now you can see at the beginning of this series chapters we have binomial theorem. So binomial theorem is on how to expand an expressions like this, x plus y to the power of n. So first we talk about the coefficients. So you can see we have nc0, nc1, nc2 and all the way until ncn. Okay, until ncn. So for example, right, let's say I put one example at the same time. Let's say if I have x plus 5 to the power of 6. So the coefficients 6c0, 6c1, 6c2, and then 6c3, then 6c4, and then 6c5, and then 6c6. That is the coefficient alone. Then after the coefficients, we have the second part, which is the term in front, the x. So you can see x take the greatest power, x power n. Then the power decreases by 1 unit, x to the power of n minus 1, x to the power of n minus 2, and the power keep decreasing until x power 0. Okay, so if you apply that concept here, then for this case, we will have x to the power of 6, x to the power of 5, 4, 3, and then 2, and then 1, and then 0. Okay, and the last part is the y. So as you can see, this is y, positive y. So what happens is it takes y to the power of 0, y to the power of 1, power 2, and keep increasing until y to the power of n. Okay, so you can see here, this is going to be 5 to the power of 0. This is 0. Okay, 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, and then 5 to the power of 3, and then 5 to the power of 4, and then 5 to the power of 5, and finally 5 to the power of 6. So that is how we expand it by using binomial theorem. And the thing is, after you use binomial theorem to expand, now we have to simplify everything. Okay, so where you have to use calculator, 6c0 is 1, 5 to the power of 0 is also 1. So where this is 1, this is also 1, only x to the power of 6 remain. That is what happened to the first term. And then the second terms, you have 6c1, which is 6, 6 times 5, which is 30. So 30x power 5. Okay, then after that we have 6c2. So we have to know that 6c2 is 15 times 5 to the power of 2 at the back. So you get 375. X to the power of 4. Okay, then the next one you have 6c3. So 6c3 is 20. Then times 5 to the power of 3. 2500 x cubed. And then we have 6c4. So 6c4 is 15. Then times 5 to the power of 4. 9375. So x squared. Then we have 6c5. 6c5 is basically 6, and then times 5 to the power of 5. So we have 18750 x, and then finally we have 6c6, which is 1. X to the power of 0 is also 1. So only 5 to the power of 6 having values. So 15625. So that is how we expand it. Okay, this is the most basic one. Then we look at the next one. The next one we have NCR equal to this. Okay, so it's the formula for the NCR here. So beside this form, right, actually there is another form, okay, where I put for you also as your reference. You have to know that it is it can be this form also. I write down here, n factorial n minus r factorial r factorial. So altogether there are two forms. Okay, then let's say example. Okay, how are we going to understand the first form? Okay, the first form, you see n minus 1, n minus 2, they keep minus with greater and greater number. You see from 1 and from 2, from 3, minus 4, minus 5 until r minus 1. The bottom is r factorial. So let's say one example. Okay, so example, let's say if I have 5c3, so we have to do 5 minus 1, 4 minus 1, 3. Okay, so how many terms do we need to put? If you look at the formula, of course it is until you do n minus r minus 1. N minus r minus 1. R minus 1 is, this is r. R minus 1 is 2. So until 5 minus 2. Until 5 minus 2, which is 3, 5 minus 2 is 3. So until 5 minus 2. Okay, but my suggestion is you think like this. If the r is 3 factorial, then you just take it like this. If the bottom is 3 factorial, then the numerator will have 3 numbers. So it will be easier for us, So if you think like that, 3 factorial, 3 numbers. Okay. Then let's say you simplify this on your own, and I put another example, 6c2. 6c2, the denominator is 2 factorial, then the numerator will have 2 numbers. That will be easier for us if we put it in this way. Okay, so let's say 5c3. Of course you can use calculator, maybe you're wondering. Okay, calculator will help you to get 5c3 equal to 10 straight away, and 6c2 will help you to get 15 straight away if you are pressing calculator. But the thing is, we need to know the formula at the same time, so that when the question gives you unknown, then you still know how to solve it. Okay, you still know how to solve it. Okay, how about this formula? Let's see. This formula. Okay, so if let's say same example again, 5c3, and if I'm using that formula, so it will become 5 factorial over 5 minus 3 factorial over r factorial, which is 3 factorial here. Okay, so at the end, if you simplify this will be 5 factorial, 2 factorial, 3 factorial. I'm trying to show that it is the same in this way. So you imagine 5, 4, 3, 2, 1 on top, the bottom 2, 1 for the first bracket, 3, 2, 1. Okay, let's say I cut this away. Then you will realize that it is the same with, you see this one is the same with this one, 5, 4, 3 on the numerator. At the bottom 3 factorial, which is 3, 2, 1. It's the same. So at the end should be 10 also. Okay, so that is 5c3. What else we need to know here is the general term. The general term. A general term is like, this is the first term, this is the second term. So after simplify, this is the first term, this is the second term. So let's say I write down, this is T1, first term, T1, and this is T2, T2, this is T3, T4, T5, 1, 2, 3, 4, 5, 6, and 7. Okay, so first of all, when we talk about the term, you need to know that how many terms are there in a binomial expansion. So it will have n plus 1 terms. That is the first thing. Okay, n plus 1 terms. So if the power is power 6, then they will have 7 terms. So the number of terms in the binomial expansion is n plus 1 terms. N plus 1 terms in x plus y to the power of n. And let's say we just want to know one particular terms. Let's say, oh, I don't want to know the full expansion of the whole thing. I just want to know the fourth term, let's say. So there should be a formula. Okay, there should be a formula to represent any terms here. Okay, so as you can see, there are certain pattern, right? So it should be a formula. So the formula is, if you want to find tr plus 1, so why I use tr plus 1? Because if the r is 3, right, the number of term is 4. So that's why I use tr plus 1, where the number of term is 1 unit greater than the r. 6c, this is nc, r is 3, but here is r plus 1, 4. So in general, if I want to find r plus 1 term, so I'm going to use this formula, NCR, then the front part, x to the power of n minus r, then y to the power of r. Okay, so that is the general term. Okay, so how to use this general term? Let's say one example. Okay, one example, if I have x plus 1 over 3x to the power of 4. Okay, so then the question wants us to, okay, let's say greater power, power 6, or maybe power 8. Okay, so they ask you to find the coefficient of the term with no x. Find the coefficient of the term with no x. So which term is that? If you go and expand, right, you will have 9 terms, So it is wasting of time if you go and expand it. But if you use this formula, then it will be easier. It will be easier. So tr plus 1 equal to, the n is 8, xcr, the x, then n minus r, the y is this one, 1 over 3x to the power of r. Okay, so from here, right, we can figure out which one, which term will have no x. So no x means x to the power of 0. X to the power of 0. Okay, so I can simplify this thing by purposely gathering up the x. Okay, in this way, as you can see, xcr, I remain it, and then I purposely separate the 1 over 3 to the power of r from here. As you can see, I do it like this, 1 over 3 to the power of r, 1 over x to the power of r. So I purposely separate them, and I gather up the the one with x. So I want to simplify the power. So 8CR 1 over 3 power r, x to the power of 8 minus r again. So imagine this bracket at the back is x to the power of minus 1 to the power of r again, so which is equal to x to the power of minus r. Because of that, we add up the power. Okay? They are multiplying, right? So this is multiplying with this, so we take this power, add up with this one, so end up with this. And let's say I simplify it. xcr 1 over 3 to the power of r, x to the power of 8 minus 2r. We know that the term with no x, right? So the power should be 0. So this power should be 0. So 8 minus 2r is equal to 0. R is equal to 4. So when you know r equal to 4, then we know that this is tr plus 1 after we simplify. So when r equal to 4, then we know the fifth term as 8c4 1 over 3 to the power of 4 x to the power of 0. Then we will get the coefficient. So 8c4 times 1 over 3 to the power of 4. Then we get the coefficient as 70 over 81. That's the coefficient. And that is how we use the formula of r plus 1 term. Okay, so let's move on. 7.2 Aromatic Progressions. So aromatic progression is where the terms are like, let's say the first term is A, the second term is A plus D, the third term is A plus 2D, the fourth term is A plus 3D, and so on. So this is aromatic progression, where you want to get, the first term is known as A. To get the next term, you plus D. To get the next term, you plus D again, and you plus D again. So the D here is common difference. So this is called the first term, which is U0. U0, this is U1, U2, U3. Sorry, this is not like that. The first one is U1. Okay, U1, U2, U3, U4. Okay, so in general, to find any terms, okay, you use UK equal to A plus K minus 1. You can see here, this is 4, this is 3. So this is K minus 1. So K minus 1D. So this is the general terms to represent the aromatic progression. And then this is the formula to find the sum. So let's say you want to add up the first 4 terms, and then you put S4. S4 equal to 1 over 2n 2a plus n minus 1d. So this is the formula to find the Sn. Okay, so I give two more formula. So beside this formula, you can use Sn equal to n over 2 a plus l to find the sum of the first n terms also, where l is the last term. Okay, but the limitation of this formula is we can only use it if you know the last term. If you don't know the last term, then you cannot use. Okay, so if you don't know the last term, then you have to use this formula. This formula can be used if you know the first term and the common difference here, the d. Okay, then d is basically the term at the back minus the term in front. So to get d, we can do like this. And to find n term, there is also a formula where you can use Sn minus Sn minus 1. So that is to find a general terms. So these are the formula for aromatic. So I move on first. Geometric progressions. So just a quick review. Geometric progression is, first term is A, let's say, Then the second term you multiply with r to get the second term, ar. Then you multiply with r again to get ar squared. This is the third term. Then ar cubed, and so on. Okay, so geometric progression is where we take the first term, multiply with r, and r again to get the next term. So again, you can see this is u1, u2, u3, u4. Okay, so in general, uk is equal to ar to the power of k minus 1. So you can see this is k minus 1. Okay, so the r here is called common ratio. Then we have also the formula to add up the first n terms. So to add up the first n terms, so we use this formula, a 1 minus r to the power of n, 1 minus r. So of course there is another option here. Normally we use this option when r less than 1. Normally, okay, so and the other version is in this way, a rn minus 1 over r minus 1. And normally we use this version when r is greater than 1. Okay, so we also have s infinity. S infinity. This is sum to infinity. Sum to infinity is only happens in geometric progressions where when they fulfill this condition, modulus r less than 1, or when your r is in between minus 1 and 1, when they fulfill this, then you will have sum to infinity, okay, as a number. Okay, as a number. If they don't fulfill this, right, your sum to infinity is infinity straight away. So if they fulfill this, then it will have number like this. Okay, so you can use this formula to find out the number. We call that limit. So let's see one example. Yeah, these questions. So it's the application on what we learned. So you see here, a small trading company make a profit 250,000 in the year 2000. The company considered two different plans, Plan A and Plan B, for increasing its profit. Under Plan A, the annual profit would increase each year by 5%. By 5% of its value in the preceding year. So under Plan B, the annual profit would increase each year by a constant amount, D. Okay, so 5%. So I have to say that when they give percent, it is geometric progressions. For this case, increased by the constant amount. So this is like the common difference. So this is arithmetic. So Plan A is geometric, Plan B is arithmetic. So part 1, find for Plan A the profit for the year 2008. Okay, so let's think about this. So part 1, you have A equal to 250,000. Okay, so maybe you are wondering what is my R, the common ratio. Okay, so if you are not sure, then you just do like this. You know the profit increased by 5%. So the second term is going to be 250,000 multiplied with 5%. Then you add back to 250,000, okay, to get the total profit. Okay. Okay, then you will get 262,500. Okay, so you get the second term now. So we have to know that to find the common ratio in general is like this. You take the, okay, here I use T. Okay, let's say I just make the the term same here. So let's say I change it to u then. I change it to u to represent the term. Okay. Likewise, for common ratio, okay, so I use un over un minus 1. So you just need to take the terms and divide in this way. Take the later term, divide by the previous term, then you will get the common ratio. So let's say, for example, for this case, you want to find common ratio. You take the second term, divide by the first term, then you will get the common ratio, 1.05. And now they want us to find the profit for the year 2008. Okay, so you think about it. Your U1 is year 2000. Your U2 is year 2001. U3 2002, and so on. So 2008 should be U9. Okay, you have to think about it one by one. Okay, and then we know that we are looking for U9. So we use the formula AR to the power of n minus 1. So A R to the power of n minus 1. Then we will get, in terms of three significant figure, I get 369000. Okay, now part 2. Find for plan A the total profit for the 10 years from year 2000 to 2009 inclusive. Okay, so that means you have to include this year and this year. Okay, the profits on these 2 years. Okay, so that is going to be S10. S10. Okay, so part 2, we need to count S10. So we use the formula of geometric Sn formula. So which is A then the R is 1.05. Okay, let's say I use Rn. Rn minus 1 divided by R minus 1. Okay, then we press calculator for this. So in terms of three significant figure, it will get 314,000. Okay. Now part 3. Find for plan B the value of D for which the total profit for the 10 years 2000 to 2009 inclusive would be the same for plan A. Would be the same for plan A. So that means we have the same total profit. Okay, so plan B is aromatic. So A is 250,000. Common difference is D. So S10 is 10 over 2 2A. I'm using the Sn formula for aromatic, plus 10 minus 1D. So equal to, they have the same profit with this one. So of course, to make it accurate, so I'm going to use the accurate value, 314,473.134. This is the value in my calculator. So I just need to solve this, and then I will get D. Okay, I will get D. So divide by 5 minus with 2 times 250,000, then divide by 9. Okay, So in terms of three significant figure, I will get 1, 4, 3, 0, 0.